Hey everybody, thanks for coming to my talk. Give me a second while I put you up in the corner. Put myself up in the corner. So we're going to talk today about metrics. And so here's a little bit about me before we really get rolling. I'm now a developer of things at Red Hat. I was an IBMer for 21 years. The important things that are most relevant to this talk is that I'm a dungeon master for 11-year-olds and I build really ludicrously ridiculous things. Before we go into metrics any more than that, I do want to take a little bit of time to go over the bigger landscape, right? So we talk a lot about orchestration right now. In orchestrated environments, we need our systems to be observable. We need to be able to understand what went on the inside of any individual service based on what we've already gathered on the outside. The ability that, you don't have the ability you used to go recreate a problem with trace turned on. Like, you've got to be able to figure it out based on what you have, or at least get reasonably close to any kind of problem determination. I include health checks in my own view of observability. Any service, needs to be able to, you need to know, is the service healthy? Is it ready? It's not a zombie, that kind of thing. From a metrics perspective, you're looking at statistics, analytics, big trends, right? It's all how many times has the method been called, how many 200 responses, how many 500 responses. You're not looking for individual instances, you're looking for trends. Is there suddenly a big spike in the number of 500s, right? That's the important part, not so much that any one request had a 500 response. When you're looking at log entries, that's where you get specific. So the log entries are where you can say, here's the stack trace for this exception, here's the parameters that came in within reason to be safe. But that's when you get all your real rich instance context, right? Your service specific context, so you can understand what happened. Distributed trace, again, is that end-to-end flow. It's how all of the services in your system work together. And you're looking, again, for context. Relationships between services, it is very rich, it's sampled. So you don't get every single request this way, but you get a sampling. So if this user request is traced, then the services that request invokes, right, those get traced, and the resources that those get used get traced, but not all user requests will get traced, which is just a caveat to remember. Both the infrastructure and the application have a role to play in creating a comprehensive observability story. There's things that the infrastructure can do from a generic sense. It'll provide default probe behaviors, maybe based on whether or not what it can inspect from a generic container perspective. Maybe it can gather some metrics based on the resources available for the node. The infrastructure is usually what provides your log collection infrastructure. And some aspects of your infrastructure might be ensuring that span tags are present on HTTP requests if they weren't before. So it's hey, I'm a router or a proxy or a service mesh, and I'm seeing this request, and it doesn't have a span on it, so I'm going to add one. What the infrastructure can't do is the application-specific stuff, right? It can't say, oh, this is a Java application that needs these resources to be available before it can service requests. It can't know application-specific metrics that would be good to gather to make sure the application is doing the right thing. It can't emit that rich, structured or unstructured log text so that the service maintainers, right, can understand what happened when a request passed through the service. And the generic infrastructure can't necessarily do that span context propagation because it's not aware of the relationships between things, not without some help. So as application developers, you have a role to play in making the observability of the entire system robust. So again, in this talk, getting back to where we're really focused on metrics. And specifically, I'm going to be using Prometheus as my time series data store. I'm looking at Grafana for visualization. I am not going to play with heap size. I am not going to play with application memory. I am not looking at any of the usual things. I'm going completely off the ranch. We're going to just make stuff up. It's going to be great. When we're looking at metrics, we're looking at time series data, right? So regardless of what data it is, it's as it changes, you're looking as it changes over time. So you're never looking at one data point, You're always looking at an aggregation of data points. So that data is gathered from, all of your services in the system. It's gathered at a nice regular cadence, nice regular interval. You have a string key, one numeric value, and that value is observed at collection time and appended to the entry, as a new entry in the end of the series, and that's where our time series comes from. When we talk about dimensional data, when we're using dimensions, that allows us to take that single recorded value and view it and aggregate it in different ways, right? And so it allows us to get different insights out of that, out of the data that we created, or out of the data that we collected. So I can look at all app memory use measurements for US, services running in data center US1, or I could look at all app memory used for services running in the prod environment across data centers, if that was going to happen, right? I could look at everything. I can look at anything related to service name in prod, or I could look for things only related to that particular instance, right? So having those dimensions just let me slice and dice and group and aggregate those single numbers in different ways. So when we talk about the cardinality explosion, it's because all of those, every unique permutation of those tags creates a new series. And that can be, oh my God, it's too big. Yes, it's a lot of data, but it's data that's stored fairly compactly, and it just means you have to be prepared to size your data store appropriately. There's different ways to partition data, to capture data with different Prometheus endpoints. There's all kinds of strategies to mitigate how big, how much data you're storing. So you can get around the cardinality problem. I think the important thing to remember is that you always want to work with bounded sets. So even if it's a bounded set that's 100 big, 1,000 big, as long as it's not infinite, you're probably okay. You just have to play with it and see what happens. So yeah, don't use a UUID or a request ID or a user ID, even in the case where your user ID could be any number. Don't use those as values for your labels, because that's when you start getting into trouble. Working with aggregates. So we have, this is just a point I want to make again, you're working with aggregates in this case. You're not getting back to single values. In most cases, as soon as you even have it show up in a graph, you have already done math to obfuscate that original measurement, right? Maybe you're taking it from 2 instances or 3 instances or 4 instances. So already whatever was measured is, there's no way. Just don't even think about getting back to the value, the original measurement. It's always aggregated. You're always looking at some sliding time window. When you're looking at aggregates, take the time to put the statistics hat on and make sure that the data that you're graphing is valid. If you are pre-computing averages, if you're pre-computing histograms, if you're pre-computing percentiles, and then you try to aggregate them later on a dashboard across dimensions, you may be doing math that doesn't make any sense anymore. You cannot actually, it'll work, it'll let you do it, but what you're looking at is not what you think you're looking at, because you're not looking at the overall average, you're looking at an average of averages, or you're looking at numbers where the scales might be completely different once you start taking different tags into consideration. And so you're making an aggregation of things that don't make any sense. And they might look pretty, and they might make you feel good, but they might not be measuring what you think they're measuring. So just take the time to put the statistics hat on and make sure that the aggregates that you're gathering for those pretty dashboards are legit and that the math works out. So this is about the 10-minute mark, which is about good, because let me tell you, the next, we're going to go way off the reservation and into serious nerd land. So I hope this is fun. This is where I had fun anyway. So this started a year ago. I offered to be a dungeon master for my 10-year-old. And that meant I had to go from vague sort of kind of remembering about Dungeons and Dragons from that one time that I played when I was 11 to being able to herd 6 10-year-olds through a Dungeons and Dragons game, and knowing all the rules. And, I had to know enough to keep them entertained and engaged and on the beaten path, right? So I had to learn a lot in a very small period of time. And the part I was actually the most worried about was combat, because I knew that was the part that they were going to be looking forward to the most. And I wanted to understand how it worked. I didn't want to have to be going back to my rule book to figure out, like, okay, what does any one thing mean? And so I wrote an app for that. I basically coded the combat rules so that I would understand how it worked. The simplest form of the combat rules is here. So I went to the wiki page, the OpenSRD document for Dungeons and Dragons, and I got 215 monsters that I could work with. And I parsed the data out, made a JSON file for them, so my app can now read the JSON file. And then I take 2 to 5 of those monsters at random and smush them together into an encounter. The simple encounter rules is you roll for initiative, you go in order, right? You take a round and everybody takes turns in that initiative order, and you beat each other up until only one monster remains, and then you have a winner, and that's great. So as we go through some of these other things, and as I was coding it, I started to think about other things too. So again, I just wanted to understand how Dungeons and Dragons worked and how combat rules worked. That was my initial motivation. As I'm coding all of this stuff, I started to think about, well, I'm making choices for how one monster chooses to attack another monster. That could impact how the battle goes, right? Like, okay, so then I changed how I was doing those encounters, how I was doing those target selections, so that I could look at that and I could see how they changed the outcome. It's something I ended up measuring and making some alternate paths for. As a thought that, well, then if I wanted to continue to improve or change or average out or make more consistent or something the encounter length, then those algorithms are what I would use to tweak, and I would have the measurements to back that up. And the last one is that's really, really where my whole thinking around application-centric message or application-specific metrics came from, which is, do I actually know that my application is doing what it's supposed to do? Because I could have great metrics for 200s coming out everywhere, and it doesn't matter if I'm not actually executing code, right? That doesn't work. So that's kind of where I came from. So we're going to go through this really fast because there's only so far you want to go off the nerd side of the road. So monster syntax, right? Monsters have a size, a type, an armor class, and a hit points. And armor class is how hard it is to hit. Hit points are how many hits it can take before it dies. Monsters use weapons, a bite, a claw, short bow, short sword, long sword. There's a list, right? And those weapons inflict a type of damage: piercing, slashing, bludgeoning, poison. There's a couple others. And then there's another formula that's often used, right? And you can see in 2 of these roll d10s, 2 of these are 2 8s. The last one is a poison. It's a 22 d6. Like, that's just like all the dice, and you roll them, right? So they inflict damage. Monsters like ancient green dragons, they have multi-attack, right? And so if it's present, you want to do 2 claws and 1 bite, which makes their turn a little more lethal than it might otherwise be. When I try to put those into a battle, this is a trace here, a log, right? Here's my logs for 1 round, where I have a troll and a pit fiend fighting each other. Now, when you're going to make an attack, you roll the ubiquitous d20, right? If you roll a 20, that's a hit, it's double damage. If you roll a 1, it's a critical miss, no damage. There's 2 things that can happen otherwise. One is I'm an attack against an armor class. So here I've got my mace. I'm going to add 4 because I'm good with it, and I'm going to smash you. And what that can mean then is if I roll a 16 and your armor class is 11, I hit you, you take damage. If I roll a 9 and your armor class is 11, guess what? It bounces off your shield and there's no damage. The other kind of attack is different, and that's a spell attack, or in the case of the ancient green dragon, a breath, like the breath weapon attack, right? That attack just hits. It gets some damage and it just hits. And then it's up to the person being attacked, the monster being attacked, to roll a saving throw, as they call it, which is still a d20 with some modifiers, to save against that effect. And that kind of attack has a very different characteristic. And this is something where, since I started playing with this last September, I've done a lot more to change my measurement to really pull out the difference between these two kinds of attacks, because their characteristics are fairly different. So my application is in GitHub. You can go look at the data. I have a couple endpoints. The only one that I use anymore is combat any. I'm using labels like mad. And for sanity purposes, what I ended up doing is I ended up creating a single class called combat metrics that holds all of my metrics, all of the measurements that I'm taking from encounters. And I did it in one place so that I'm not chasing my tail if I decide to change my mind or if I need to tweak what I'm gathering. So at initialization time, I'm setting up some gauges. I'm looking at, I set up a handler, basically a monitor, to get dice rolls so I can keep track of what the dice rolls are. I have a measurement that happens at the end of an encounter, right, where I'm looking at the number of rounds. And here's where I'm looking at the number of combatants, or the target selection, or the difference in size between the monsters in the encounter, because, again, those were things I started to suspect might influence how long an encounter lasted, how many rounds there were in the encounter. At the end of every round, like here, I'm looking at the number of attacks per round, and I'm tracking the damage. And what I'm looking for here is, did it hit or did it miss? What kind of attack is it? Specifically, is it an attack against AC, or is it an attack with a saving DC? That's that attack type. The damage type is piercing, bludgeoning, slashing, that kind of thing. And I do have the target selector in this one also, to just understand, like, who did it target? Who did this attack target? With the damage per attacker. Notice I'm tracking the damage amount in this one also, but I have it in a separate distribution summary using Micrometer. I'm getting a distribution summary because that gives me a max, a count, and a sum, which means I can calculate my own averages after I aggregate them in whatever way I feel like based on these labels. And I separated this out into its own summary because attacker and attack name are both fairly high cardinality items. Like, they're labels that have fairly high cardinality. Keeping them separate from the other ones does reduce the overall size of the data that I'm dealing with at the end. So it was on purpose. It was a way to manage the amount of data that I was producing. So if we go and quick look at the encounter resource, right? Here's our any. This is the Quarkus one, but the Spring one is almost identical. So if I say go, I'm going to make my encounter with however many beasts I need, and I'm going to choose a target selection algorithm, right? One of these. And then I'm going to run a round, measure it, and then measure again when the encounter's done. That's it. So the code for creating these measurements is fairly clean. All of the measurements are constrained into one class. I'm not running willy-nilly everywhere. The important thing you might look at when we start looking at data is I'm taking 3 Booleans here. Is critical, is saved, is hit. I'm just doing general string assembly so that I get one, finite set of values for a hit or miss label out of basically 3 Booleans. So I'm compressing those down into one. And then again, for the attack, I have an attack with it if it needs a save or if it's against an armor class. So if we take a look at some of the numbers, a dice roll ends up looking something like this, right? I'm using a counter, so it's going to have the total. Oops. And here's how you look at a D10. How many times I rolled a 9 on a D10, right? When I first plotted this, and of course I blew my surprise already, something was obviously super wrong. And you can notice from this roll the dice side over here, right? I had 28,000 dice rolls total, and I have rolled the D12 1,400 times, basically, 1,400 times. That is not right. That is not that's the wrong distribution. There's no way that should happen. So what on earth did I do? And it turns out, had I had a pair programmer, I'm sure when I was doing all of the dice rolls, I would have noticed that I didn't put the D12s in the switch statement, which is what I did. But I was writing this one by myself, and I didn't. And I am quite sure, completely confident, I would never have found that error without this glaring graph mistake. So it was like, win for metrics. Now, hits and misses, right? We talked about this one where I'm looking at here. You can see here, there's an attack with armor classes, and then I've got some that are attacked with difficulty class. So I've got the two kinds. You can see the hit or miss attribute with miss and critical hit over here on the side, right? That's great. First time I did it, I got this critical saved hit thing, whatever that is supposed to be. Critical saved hit is not a thing. It doesn't exist. So that basically meant something when I wrote the encounter and tried to go through the rules and the statement, parsing in what the various attacks were, and then trying to decide which attack it was and what path it needed to go through. Yeah, did something dumb. It was, I don't even remember what it was, but it was one of those, you just dump it on the floor and you rewrite it again. So I got that done. I did it again, and it was great. It was fixed, except that it wasn't, because critical hits were happening more often than misses, which should not happen, right? Misses should be completely common. And this was the case where, and I don't know that I would have found this one either, this is a data entry problem. When I was reading from that original wiki page, I had a regular expression wrong. And so nothing had an armor class more than 9. Would never have found that without metrics, because you can't, you're only going to look at logs for so much. The rest of it, it's too much data to absorb. When you try to graph it, it makes sense. When you're looking at these big aggregate numbers, the trends pop out like that. Brilliant. Absolutely brilliant. So if we step over to look at some other dashboards, oops, wrong way, this way. There's a couple things that we can look at. So just to show you, right, the updated dice, it all is nice and pretty. Everything is pretty distributed. If I look at that the attacks by hit or miss again, this is just that one measurement. I'm taking the different dimensions and I'm slicing them in different ways so I can learn different things. So I have, just for reference, right, attacks with a DC are way less common than attacks with an AC, orders of magnitude less common. And if you look up here, when I stack them all together, right, critical hits, critical misses, right, those are pretty low. Attacks are pretty common. Misses are the next most common. And then these DCs, again, are even less frequent than critical hits. They just don't happen very often. When they do happen, you save more often than you don't. That's a good thing to know, because, as we'll see, but you save more often than you don't. Then if I look at the damage by attack type, this is one of those places where I started to appreciate some nuance. So the easy part of this graph is to see that a hit with an AC is about a 14 points of damage, 15 points of damage on average. That's okay. And then when you have a critical hit, it's about double. It's a little less than double in this case, which is fine, right? It's about double. That's about right. That's exactly what you would expect for a normal armor class hit. What I did not really appreciate until I did this was that an attack with the DC, here, let's up this to like 3 hours, right? You can see it dances around a lot. What I didn't appreciate was that an attack, these DC style attacks, they're effectively critical hits. Like, they're double damage. And then when you really think about the next part, which is like, well, of course, because when you save, you take half damage. But it's like, wow, I just did not fully appreciate how much some of these save DCs will just wreck you. It's just ridiculous. And even if you take then with this lower average here for AC, where this is taking into account the misses, so it brings the average down a little bit. Like, that's just an insane difference in the amount of damage. Now, one of the other things that I found interesting in terms of, me learning as a DM and understanding how to slice and dice the data is when I started looking at damage by damage type. So frequency, right? Most common, piercing, slashing, bludgeoning, by far the most common types of damage, with slashing and piercing being the most frequent, especially in the monster space because of teeth and claws, basically. You end up with piercing and slashing being really common because those two attacks are so common. You get like everybody else kind of way up here, and it's just not as much up there. But what has happened every single time I have let this run for a long time, the top two, lightning and poison, without fail. The rest is kind of like this higgledy-piggledy mix. You can see right here a real dense line in the middle where you have an overall average hovering at around 10 points of damage. slashing, piercing, bludgeoning. Those are the three most common types, and they are all right there. But lightning and poison, man, they're just through the roof. So if I zoom in even more and we say, all right, let's just look at lightning and poison damage. Let's see what they do. I am not changing, by the way. I'm not changing my measurements. I've made no code changes. This is just doing the math a little different to pull out, using these dimensions to really focus on the behavior of these two types of damage, right? So if I look at the damage by this attack type, right, the armor class versus the difficulty class style of attacks, right? Look at this. They're not. Lightning is a difficulty class, right? It happens way more often, and it just smashes you with a DC-based attack. And it doesn't happen, I think it doesn't happen very frequently to begin with on an AC style attack, and it doesn't do as much damage there. With poison, you're closer to even. So it doesn't matter if you get bitten with some extra poison damage or they had some poison breath thing that you tried to save from. Poison is still just not your friend. And when you look here, if we sort this by hit, right? If you look at the attack and hit point, right? If you had like the hits versus a saved hit, lightning is just, even if you save it, you can survive if you're a squishy young character, maybe second level, first level, you're done. Lightning will it just puts you right out the back door. So you can save, you can survive some of these, but so what this changed is, what this taught me as a DM, what this taught me is that when I'm making my own characters, which of course I have done since then, I don't neglect the Constitution score, because that's what saves you against poison. So it's like, oh, it's not a dump stat. No, you need that. There are other graphs in here. One of the things I talked briefly about was that target selection. And so I'm going to pin this by 4. So I'm only looking at the encounters that have 4 monsters in them. So they're pinned. That's pinned. And here's where we look at, oh goodness, my size delta is wrong here. This is supposed to be by size delta, this one is. Let's fix that. Yeah, that's better. Let's go back here. So we have, this is the target. No, I did it right the first time. I was looking at 2 things. We're going to do target selector first. So again, we're taking the same data, we're just showing it in different ways, right? So if we look just at the target, here's the number of encounters total, the total number of encounters that have these different target selectors. And you can see we're at 424 overall. Here's your increase in size over that. So that's just the counter overall. We have the most incidences of having the biggest first. And then when you look then at rounds, right, we've got an order of magnitude bigger for rounds, which makes sense because you have multiple rounds per encounter. And again, the math makes sense, right? You see the same general shape, except you notice something's different with random and smaller first, right? Random has fewer rounds per encounter, just looking at this, right? So what does that actually mean? So let's look a little more detailed, right? If I look at the average number of rounds per encounter, where the overall average is 7.5 rounds per an encounter with 4 monsters in it, if those 4 monsters consistently choose just another monster in the thing at random, that is the most effective approach for closing the encounter quickly, which I find crazy. So fewer rounds, if everybody chooses randomly, than if they try to pick the one with the lowest health first, or if it's the smallest, or have it and just don't pick the biggest first. This whole thing, every time I've seen it, just don't pick the biggest first. It doesn't work. Your encounter takes forever. So that's my lesson learned just from that. So I'm at 29:28, so I'm going to stop. But I hope this was interesting. I hope it gave you a different way to think about your metrics and about how you're measuring your applications and what you can learn about whether or not they even do what they're supposed to do, which was the point. So I thank you all for coming, and I really hope this was helpful. Please continue to ask questions. Find me on Twitter. Find me wherever. Thank you so much for your time today. I just appreciate your time. Thanks.